Okay, here I'm going to do two problems. In number 2, we have our region to be -1 by 3, that's the x values, by 0 to the y values. So -1, 3, 0, 2 is going to be right here. And m is 4, n is 2. Delta x is defined to be b minus a over m, and delta y is d minus c over n. So this is a, b, those are always x values first. These are the y values. So delta x is going to be 3 minus a minus 1 over 4, which is 1, and delta y is going to be 2 minus 0 over 2, which is 1. So our rectangles are 1 by 1. So delta A is 1 for each one of the rectangles because they're the same size. So we're going to divide it up like that on 0 here. So we're going to have 8 rectangles. And it says we want to find the integral, double integral over this region of y squared minus 2x squared dA. And we want the upper left corner. So that gives us a point to evaluate this function at. So in blue, we want to do the upper left of these 8 rectangles. So we're going to have f of first one is -1, 2 plus f of 0, 2 plus f of 1, 2 plus f of 2, 2 plus f of -1, 1 plus f of 0, 1 plus f of 1, 1 and f of 2, 1. That gives us all those points times delta A, which is 1. So we can kind of forget about that. So then we're just going to plug this in. This is our f of x, y. So we're going to plug each one of those points into that. And that's going to give us 2 plus 4 plus 2 minus 4 minus 1 plus 1 minus 1 minus 7. We're plugging all these points into this function here times a 1 by 1, and that's going to be -4. So in this case, it doesn't represent volume because it's a negative value. It's the volume on above the plane, the y-x plane, minus volume below it. Now, if we were to use the midpoints here of each of the rectangles, let me draw the rectangles again. You have 8. We would use these points. And since this is -1 and this is 0, this is -1/2. This is 1/2. This is 3/2. This is 3s, and so this is 5/2, and this is 1/2 and 3/2. So those points are going to be -1/2, 3/2, 1/2, 3/2, 3/2, 3/2, and 5/2, 3/2, and also -1/2, 1/2, positive 1/2, 1/2, 3/2, 1/2, and 5/2, 1/2. So you would find the f values for all of those and then multiply by the area of the rectangles, which is 1. If we were going to use the upper right corner, we would be using these points. That's -1 to 3 again, and this is 0 to 2. So, actually, so that'd be 0, 1, 2. So we would use 0, 0, 1, 1, 1, 2, 1, 3, 1, 0, 2, 1, 2, 2, 2, 3, 2. For our values, add them all up, and then times the area, which is 1. Okay, let's do one more, or well, actually 2 more. Here we want to use the midpoint, and if we look at the curves, if we take a 1 by 1 rectangle, so delta A will be 1, and the level curve, the midpoint of that is around 11, so the double integral, that's approximately f of 1/2, 1/2. So I would get 11 times 1 times 1 is 11. Now, if I did the same thing, 1 by 1, and divided into 4, then this would be a half, and this would be a half, and took the midpoint of each one. Well, this kind of goes through 11. The curve that goes through here is like 13, and the one that goes through this one is about 9, and the one that goes through here is about 11 again. So the values, we would do f of 1/4, 3/4 plus f of 3/4, 3/4 plus f of 1/2, 1/2, and f of 3/4, a half. And so this is about 13, this is 11, this is 11, and this is 9. And we multiply that by delta A, which delta is delta x times delta y, which is a half times a half, which is a fourth. So the width of the rectangle and the height of the rectangle is 1/2. So that's going to be times a fourth. And so if you work that out, that's about 11 also. So we're going to say that the double integral of r over f of x, y, dA is approximately 11, because we started with one rectangle and we moved to 4 rectangles and we got the same answer. And then you could do 16 if you want to, but we get the same answer, so we'll say it's about 11. We're just approximating. Okay, for 12 you have to draw a picture, and we have z equals 5 minus x, so that's in the zx plane. Here's 5, and here's 5, so it kind of does that. And if you do the level curves, then this area is going to be 5 by 3. This region, let me kind of draw this good. And then we have it like this. So it's a triangular region. So the volume of it is going to be the area of the cross section let's say right here, this triangular piece times the width. Say W here. Because you're taking the cross section and you're going to chop it all up and add them all up. So the area of the cross section is a triangle, and the area of a triangle is half base times the height, and the base of that triangle is 5, and the height of the base, again, the height is 5, and the width is 3. So we're done. You can do that using geometry. And that's what they want you to do there. Okay.